It's recording.
Just recording.
Nice.
Cool.
No, it's on that. It's on window. It's on desktop or window.
When is this?
Did you are you streaming your desktop or your window?
Desktop.
Okay, cool.
So good, right?
Yeah, it's fine.
Right, how do I maximize this?
Just press down. Let it go.
Right. Okay. Cool. So this is CVEN21. Okay. CVEN2101. How do I turn off auto rotate? There. All right. Cool. CVEN2101. So engineering construction. This is gonna be a recap workshop. So you got me, Aryan, and we got Rando here. The way this workshop's going to be formatted is we're first going to go briefly on the theory, so just modules 5 to 9, and then we're going to do the multiple choice questions and then finish it off with the long response questions. Sound good? Cool. So first of all, module 5, the way it starts off is permanent structures. So it's masonry and other structures, so steels, timbers, stuff like that. So essentially what we have to remember here, masonry is just bricks, right? So bricks, columns and stuff. The main thing we need to know for this is the pros and cons, because they might ask us questions on that. So the pros is non-combustible, pest and weather resistance, thermal and sound insulation, long lifespan and cheap. However, it is heavy. It's very foundation dependent, weather restricted, so mortar. Very slow and labor intensive, and has very low strength to weight ratio. So yeah, and then we got some other stuff. So like what shows a good brick, and we do measure the strength of bricks through falling. So we drop it from 1.25 meters. Um, if it stays, it's good. If it doesn't, then it's bad quality brick. Cool. Common bricks are common face, fire, paving, glazed, faced. Those are all. Some of them are aesthetic. Some of them are for purposes. So like for your fireplaces, you'll be using fire bricks. Cool. For masonry, this will be coming in your long response questions. You will be looking at these formulas. So the volume of mortar per brick, volume of mortar total, the overturning moment, and the resisting moment. We want it to be so the moment overturning and the resisting moment are equal. That's how we'll find our our safe unbraced wall height. So yeah, these are the formulas we use. Some other structures we have, as mentioned before, are the timber, steel, and reinforced concrete. So timber, the best part about it is it's fast, sustainable, flexible, and recyclable. However, it does have many cons. So very poor water and noise insulation, it rots, it has very high fire risk, and low load bearing. There are some ways we can improve our timber, so seasoning, 50% moisture, preservatives, oil paint, and stuff like that. And then we have steels. So those are mainly used for columns, cables, beams, and trusses. So they're strong, lightweight, ductile, recyclable as well. However, they are very costly, corrosion prone, weakened by heat, and have lots of buckling risk. Reinforced concrete is the last one we talk about in Module 5. So this one bases more on foundations, piles, columns, beams, slabs, walls, and stairs. The good thing about concrete is we do have like pre-cast concrete. So they cast it beforehand and then they can place it in place. So that's faster construction, more sustainable, safer, and higher accuracy, and very reusable. And then we have Dinsel walls, Dinsel walling. I'm pretty sure this is a new thing that's coming out. It's not used that much, but it is faster, cheaper, and safer than most conventional formwork. Sorry. Cool. Moving on to module 6. So this is a pretty short module. It goes by really fast. It's essentially on sustainability and digital engineering. So on sustainability, it's mainly on the environmental aspects, so the emissions, biodiversity, water and energy conservation, and renewables. We also focus on the social part, so how much water are we using, how it's going to affect food, education, healthcare, and safe living. We do use a lot of our budget on building non-moving stuff. Some of the things that the lecturers might have talked about is how in for the buildings in the US 2005 study, they've been using 40% of their energy and 70% of their electricity use just on that. Now, obviously, we're going to be using more buildings as our population grows, but we're aiming to use only 40.5% of our energy by 2030. So only a 0.5% increase. Another thing to keep in mind are the 6 R's. So this is the main part about sustainability. So replace, reduce, reuse, re-engineer, reclaim, and re-educate. They are pretty self-explanatory, but it's just on that part. They might ask a multiple choice question on this. Then we've got digital engineering. So this is more about how engineers collaborate. So the digital tech, tools, and processes for design and development. They have this big screen on the lecture slides where it has the kind of mind map. I like using that to kind of visualize it, but it really isn't that complicated. You just have many like tiers. So the people who make it, and then the contractors, and then it just goes down from that. So for one building, you might have like 50 companies, but each company is doing their own little thing. It's just acknowledging that part. And then we have some other stuff. So for digital engineering, the reason we want to make it more digital is it's more sustainable. I mean, just keeping everything online just makes it easier rather than passing out around papers and stuff like that. And then we have some examples such as LiDAR, BIM, and IoT, as well as 3D concrete printing. So, yeah. Now moving on to arguably the more fun part about this topic, so all the transports. So we got excavators, we got loaders for module 7. So yeah, feel free to have a read of this, but essentially with excavators, they're lightweight, adaptable, low ground pressure, and confined. They can be used in confined spaces. They're used mainly for foundations, trenches, pipelines, piling, and demolition. Now, there are a bunch of types of excavators, and I do recommend keeping these in mind as the multiple choice questions will be asking on different types of these vehicles. And then the productivity equation is given in the bottom. For loaders, it is more for excavating and loading soft to medium materials. So we're looking at more LCM, LCM. Then there's 4 different types. So we've got the wheel loader, track loader, and then mini loader, and then the grapple loader. They all have their specific uses. So yeah, and then once again, the production equation in the bottom. For the diagrams I've put in the bottom, they're straight from your lecture slides. Do keep them in mind. You don't really have to like memorize them, but if you like see a drawing of it, you should be able to recognize which pieces are where. They might ask questions about that as well. Next, we got dozers and trucks. So once again, we've got many types of dozers, and then with the dozers, we also have many types of blades, right? So we've got straight blades, angle blades, universal blades, and cushion blades. For these blades, they have 3 distinct motions, so tilting, pitching, and angling. They all serve their own purposes. And we got our production equation at the bottom. We also have to know the volume. So how much of the stuff are we actually like moving around? And then we got our cycle time. So it's just the fixed time plus the push time plus the return time. Right, now we got trucks. Trucks are probably the most basic ones. We just got essentially big trucks and small trucks. This is the one which is easiest to memorize because I mean, small trucks, they're more flexible, they're faster, easier balancing, but obviously you need more drivers and more trucks. Whereas for the larger trucks, you need fewer drivers, but I mean, since they're bigger, it's harder to move around. We got our production equation in the bottom. We got our cycle time, so that's loading plus hauling plus dumping plus returning. And then we got our loading time. So that's the number of buckets we need to add in plus the excavator cycle, right? Yeah. Moving on to module 8. This one's based on the more like, in my opinion, more niche vehicles. We've got the scrapers and the motor graders. So the scrapers are self-loading, hauling, spreading, and cutting stuff. We've got a single engine, we've got twin engines. And yeah, we've got the production equation in the bottom as well. And then we've got our motor graders. So this is more used for the finishing and grading, also like cuts and ditches. in loose to medium soils. So they have a more rigid frame, so just a single axis and like less flexible. But then there's other types like the articulated frame, so more hinge based and more flexible. And we got a production equation there as well. You'll notice with most of them, they're based on volume to time, whereas this one is more area to time. And then we got our rollers. So their main purpose is for like to increase strength and stability within wherever you're using them, so the ground. So they have many different compaction methods. So they've got impact, they've got pressure, they've got vibration, and they've got kneading. Yeah, so I have a read of them. There are 4 different types. So the vibratory, pneumatic, grid, and yeah. So for this, the way we choose which type of roller to use is based on the soil type, the layer thickness, the contact pressure, passes, speeds, and also just the moisture levels in the environment. And then yeah, compared to the previous ones where they're based on LCM per hour, this one is actually CCM. Cool. Module 8, slightly more boring, but it's depreciation. So this is the more economic side of engineering. Depreciation is just the value decline from either age, wear, or just not using them. So our total depreciation is our initial cost minus the salvage value minus the tire cost. Because I mean, we can still salvage this stuff, and we can sell the tires, so we get rid of that. There are a few different methods. So the 4 that we have here are your straight line method. So that's just the total depreciation over years. We got the sum of years digit method, which is your total depreciation times your years digits over the sum of the digits. So that's also pretty interesting. We've got our double declining balance. So it's just 2 over the number of years times the book value of the vehicle at the start. And we got our marks method, which is just we have a big ass table. We just go through that, and we got different values, which we just multiply by. So it's very table based. This one you don't really calculate, just multiply the 2 together. From this, SL is the straight line is very like general, right? It's the easiest one out of the bunch. Sum of years and double declining are more front loaded, so the first few years are more like intense, so you lose more there. Whereas the marks method is the most realistic. We got our O&O costs, so that's ownership and occupation. I'll change that later. We got our initial capital cost, so that's 25% of the total price. So this price, the tax, the shipping, and the assembly. We've got our investment over interest cost, so what we're actually doing with it over the interest itself. We've got insurance, tax, and storage. That is also just table based. They give you a table for each thing. You just add them up and multiply by the average equipment value. And then, yeah, the total ownership cost is just all those 3 costs added up. The actual occupation cost, so actually using them, is your fuel is based on your horsepower times the time factor times fuel price with all the conditions consumption rates. Our service is essentially the same plus the service factor, right? Service cost factor. Our repairs are just what they do is they kind of estimate how much repairs you would need, and they just do that over the total lifetime. So factor over the initial cost minus tire price, and then yeah, so cost over hour you can find through that method. Tires are usually just 1.15 times the price over the expected life. So obviously depreciating, and then yeah, the operators, so actually paying people to use these vehicles, so overtime, insurance, super, and bonuses, and then there's some other special items, so like if anything needs to get replaced. And our last bit of theory is going to be just buy, lease, and rent decisions. So why do we buy, why do we lease, and why do we rent? There are a difference between these. So we buy is fully tax incentive. So we have full control. We can do whatever we want with them. However, obviously it costs more to just buy some stuff outright. Lease is low initial cost and it is tax deductible and has easier upgrades, whereas rent has no initial cost and is very flexible. So it's more used for those smaller scale projects. And then, yeah, insurance is public liability. So, yeah, insurance, public liability versus compensation, whereas it's just injured employees. Just know the definition. You don't really have to understand it too much. It's one of those things you can kind of rote learn. Cool. And yeah, I have my cheat sheet here. It's very compact. It's literally everything I've explained in 2 pages. Cool. Now we're going to be doing the MCQ questions. Right, so our MCQs are based on every week you have those few questions. If you cycle through them, you kind of get a like 90% knowing of every single question that can pop up. But yeah, we'll go through a few as well. So for this particular question, which statement is true? So I'll be asking this to the class, so feel free to put your hand up and answer. So timber preservation is conducted to reduce moisture content. I feel like just saying all the answers will take too much time. Any answers? Yeah, what are we looking at? B. Preservation and seasoning are conducted to increase. Yeah, they are. Do you know why?
Not exactly why, but brief sort of.
Yeah, do you want to have a go?
Doesn't like preservation and seasoning just add like strength properties, but reducing moisture
Yep.
and stuff like that when you timber itself.
Yeah, that's essentially it. So yeah, seasoning is just reducing the moisture content, whereas preservation is adding more chemicals. Both of them just increase durability and age of the timber. Oh, I just got popped out. Cool. Next question. So 300 millimeters of snow has fallen. As an engineer, you want to like remove it essentially. Which piece of equipment would you want to use? So we got wheel loader, wheel dozer, motor grader, and track dozer. So very module 8 based, or 7 and 8. What are we thinking? Any answers, guys? So we're going to be looking at the wheel loader here. Now, the reason we use loaders is because they're explicitly used for stockpile material and also snow being removed, right? So you might think that you could use the not the dozer, the dozers, I guess, to like shift it away. For snow particularly, you can't. You have to use a wheel loader. So yeah, moving on, this one, so once again, another niche scenario. You have 200 millimeters layer thickness of soil. You have to spread it 1 kilometer in a cut and fill operation. The soil is relatively hard. Which one of these following equipment fleet options is not a good option to do this task? What are we thinking? Any guesses? Anyone just do a random guess? Whichever one seems the most off to you. Yeah. Number 3. Yep. So do you want to try explaining why, or is just you reckon is it?
Because loaders don't really cut hard soil.
Exactly. Yeah. So as soon as you see the relatively hard soil, it immediately loaders already out the window. Just doesn't work for that. Cool. Question 4. So you're planning to cut 100 millimeter layer thickness of soil, spread it in another place with a distance of 800 meters in cut and fill operation. The soil is relatively soft, right? Which one would you want to use this time? A few more people coming in. Any guesses? No? So good. Eamon, do you have a guess?
What's the question?
The question on the board. So you have 100 millimeters of layer thickness of soil. You want to spread it in another place of 800 meters. It's a cut and fill operation, and the soil is relatively soft. Scraper, you are correct. So scrapers are self-loading and they haul in a single pass. Sorry. So that makes it really ideal for a relatively short distance of 800 meters, or medium distance. Sorry. And yeah, it's not that thick, and it's also soft soil, so a scraper would work in this scenario. Cool. And Eamon is also gone. Nice. Moving on, we got you could add some pad and foots to on the drum surface of your current vibratory roller. Which compaction methods can be undertaken by this new roller configuration? So you've got pads and foots. Any guesses, guys? So for this one, it'll be more pressure, vibration, and kneading. It doesn't do impact because of the way it's built. It has sheep's foot style pads and feet. All that really does is really just adds the pressure and kneading. And from the question itself, it says it vibrates. So yeah, that's essentially it. Moving on, which two pieces of equipment can we typically use for side casting? So for side casting and my little slides, it is mainly just the dozer and motor grader. The excavator is more of a digging tool, so that's gone. And that kind of gets rid of options 3 and 4. And then for the sixth option, a loader doesn't really do side casting, so it is just dozer and motor grader. Which one of the following statements is wrong? So, vibration is an effective method of compacting sand and gravel. Kneading is a good method for compacting all soil types. Imposing pressure is not an effective method for compacting sand and gravel, while it is a good method for compaction of silt and clay materials. And impacting provides a good compaction result for non-cohesive soils such as sand and gravel. What do we think? So for these ones, right, we kind of like need to know why each each rolling tool is used. They're all used for their specific purposes. So for this one, it would be kneading is a good method for compacting all soil types. It is good for most of it. So it's good for clay and silt, but isn't too good for the more grain-like soils, so sand and gravel. So yeah, all soil types would be incorrect. This question, which of the following statements is wrong? Have a read. We're going to try getting an answer here. So just off reading the question, the third answer says soil compaction reduces settlement, permeability, erosion, and stability of the soil. It says reduces, so it says it reduces all four of those, which is not the case. It does reduce settlement, permeability, and erosion, but actually it increases the stability of the soil. So that's the wrong answer here. Oh, the right answer, I guess. Another question, which of these following statements are correct? You'll notice that you get lots of these types of questions. So which is correct, which is wrong, and they give you 4 statements. It's very theory-based, and you just have to understand why we use each individual component of equipment. So which statement here is wrong? The distance between loading and dumping sites does not have a direct relationship with the production of a truck. It does. The further it is, the more time it takes. The driving speed of a truck does not have a relationship with its production. Um, it does. The faster you get to the place means you can produce more stuff faster. Kind of makes sense. Last one is the cycle time of a truck has a direct relationship with its production. Oh, I kind of skipped one, sorry. The cycle time of a loader and excavator used for loading does not have a relationship with the production of a truck. It does. The faster you fill up a truck, obviously, the faster you're going to move and the better you're going to produce stuff. So that's wrong as well. So yeah, the last one's correct. I feel like this question you can do without knowing the course at all. It's kind of given. Next question here. We are halfway through the questions. So yeah, that's nice. Rand, do we need breaks?
Yeah,
Breaks.
you can do breaks.
We'll do a break after MCQ.
Yeah, sure.
Yeah. After completing the base of a road, further construction is required for drainage canals to be constructed from both sides of the road. The depth of the canal is 150 millimeters. The width is 200 millimeters. Which piece of equipment would be used to construct the drainage canals? Any guesses? So first of all, can a dozer do that? No? Yeah? Could a loader do that? No? How about an excavator? Right? So just through process of elimination, we choose our motor grader. So nice. Which statement below is correct? So depreciation is typically used for tangible assets, whilst amortization is used for more intangible assets. The sum of the year's digits is the most suitable method for amortizing assets. Depreciation is used for expensing the cost license certificates over the projected life. Depreciation can be used to reduce tax liability, but amortization cannot be used for tax deduction purposes. So yeah, this is like very niche module 9 stuff. So anyone have a go at this? Sorry? A. So depreciation is typically used for tangible assets. That is correct. That statement itself is directly from the course itself. So one of the lecture slides literally has that statement, I'm pretty sure. So yeah, it's just a true or false thing. Another one of these, which statements is wrong? Okay. Depreciation is gradual decline of the value of assets, while appreciation is the gradual increase in value of assets. Both depreciation and appreciation must be calculated for all assets of a business in each tax year. Slower pace in technological innovation and advancements typically cause higher rates of depreciation, and deterioration and wear and tear are parameters affecting equipment depreciation. What are we thinking here? Anyone want to have a go? Yeah? Third one. So slower pace in technological innovation and advancements typically cause higher rates of depreciation. That is correct. Do you want to know why? Or, I mean, sorry, do you know why?
Well, obsolescence, right? Like the equipment's going to become less useful the faster technology becomes more innovative or advances.
Yeah. So yes, the better the technology is, the more it's going to last. That's essentially it. Cool. Which of these depreciation methods results in the highest depreciation in the last operating years of the equipment's lifetime? So is it the straight line method, the sum of years digits method, the modified acceleration cost recovery, so marks, or double decline balance method? What are we thinking? So just off the formulas itself, the second and fourth one are very front heavy, which means the first few years are where it's going to depreciate the most, right? Marx does follow that sort of system where it depreciates most in the first few years and then depreciates less as time goes on. The straight line method is fully linear, so it will depreciate the same amount as it depreciated in the very first year, which makes the straight line method the answer for this question. It's more back-ended, I guess. To fast track the construction of the project, 2 excavation and foundation subcontractors are working at the same time on the site. Due to the negligence of the loader operator, the foundation's formwork is damaged. Which insurance covers the financial penalties of the damage to the foundations? So this is like the more insurance part of module 9. Anyone want to have a guess? So no equipment's getting damaged. Equipment being like the actual transport, so it's not that. It's not premium insurance. It's not compensation either. It is public liability. So that's more the negligence-based insurance. Compensation is based more on injured employees and stuff. So if anyone got injured in this, then yeah, we would go for the second one. If any equipment got broken, we'd go for the fourth one. And yeah. For a piece of construction equipment with a expected life of 5 years, which of the following depreciation methods yields the highest depreciation percentage in the first year? What do we think? So for these types of questions, if you have done practice on these 4 methods, you kind of like slowly recognize which one's which. So for example, for this, in the first few years, the double decline balance method would be the most depreciation lost. So got the first year. So it's the formula for that is 2 over the number of years. So 2 over 5, which will be 40% loss in the very first year. So yeah, that is quite high compared to your straight line method, where you're losing only 20%, and your Marx method, which would also be around 20%, and then your sum of years digits method, which would be around 33%. Yeah. Yeah, 33%. So yeah, for this one, the one that's having the most depreciation in the first year is the double balance method, or double decline balance method. Man, these questions are not ending. Foreign equipment of the expected lives of 5 years, which of the following depreciation methods yields the highest depreciation percentage in the second year? So yeah, once again, you got your 4 equations. For the marks, look at the table. For the other 3, actually like, do them. It's not that difficult. We'll end up seeing that the Marx method is the highest there for the same reasons before. As a machinery manager, you decide to buy a new wheel loader with the capital available in your construction company. What is the interest? So the investment cost of the equipment. What are we looking at here? So they are just buying it. So the answer is A. So P times I. The interest cost still applies even though we bought it, even if you're not using a loan. Sorry, it would be D. Yeah. So yeah, you don't have any interest because you're not learning anything. You're just using the capital you have. 18. Which of the following statements is wrong? Operation costs increase over time while ownership costs gradually decline over the equipment life. right? Total cost of equipment is typically at its maximum in its first year of operation. The repair cost and the rate of depreciation for a piece of construction equipment typically increases over the useful life that the piece of equipment has. An effective way of reducing the hourly ownership cost of a piece of equipment, a piece of construction equipment, is to increase the annual operation hours. So, what do we think the answer is here? So the repair cost and rate of depreciation for a piece of construction equipment typically increases over its useful life for that piece of equipment. That's the answer here. It is something that doesn't really make sense to me, but something that I just learned, honestly. Right. Question 19. So the sum of the years digits method is used to depreciate a piece of construction equipment with 7 years life expected life. What proportion of that total depreciation will be allocated to the fifth year? So purely calculation based. After using the sum of years digits, you'll come up at A, so 10.7%. And then finally, we have this. Which answer does only include grand challenges that construction industry faces? So what do we face? Do we face sharing construction documents, material shortages, slow technology uh, adoption, and number of stakeholders? Material shortage, number of stakeholders, high energy consumption in old buildings, slower technology adoption. Excessive construction waste, high energy consumption of old buildings, slow technology adoption, and material shortages, or material shortages, sharing construction documents, high energy consumption of old buildings, and excessive construction waste. Anyone want to have a go at this? As you'll notice, the previous questions were all 1.25 marks, whereas this one is 2.5 marks. They kind of do this because there's no other questions they can ask you on Module 6, so the sustainability and digital engineering part, so they usually make that worth slightly more. Anyone want to have a go? No, it's just me. There's it's only yeah. So yeah, it's the third option. So excessive construction waste, high energy consumption on old buildings, slow technology adoption, and material shortages. And yeah, that's about it for the MCQ questions. We're moving on to the long answer questions. So that'll be what Randall will be doing. Do you want to do a break first?
Do we want to break, guys? Quick 5-10 minute break, and then we'll get into the long questions.
Yeah, Jen wants to break. Okay, let's go.
Okay, amazing. Be back at 12:50.
12:50. Sure.
Amazing.
Also, I was just not in camera for most of the time. I'm moving.
Who made that?
Do you ever see?
Should we tell them about the snacks at the back?
Yeah, please help yourself to the snacks at the back.
We do have snacks in the back, so
Yeah.
like chips and stuff, and like drinks, if you like. No, that's all good. My friend, let's help ourselves with snacks.
Let's go.
You go for the snacks, huh?
All right, guys. If you're ready, we might just get started because some of these questions are quite long. So yeah, I'll just run through the 2024 long answer questions. So there's kind of like three big question types. There's like the how many equipment you need for this, like hauling and then excavating distance. There's the bricks, like number of bricks, total volume, wall thickness, that one, and then the operational costs question, which is really, really long and tedious. But like that's the main three question types that will be recycled throughout, because Mosins likes using the same papers but just changing the values. So if you're comfortable with doing these questions, like you should be chilling. So yeah, I'll just do the 2024 question 21. So your company has a wheeled loader available to load well-blasted material. However, the company has several rare dumping trucks with a struck tray volume of 20 meters cubed for hauling and dumping. The volume of loaded soil in each bucket of the load is 4 meters cubed, and each cycle time of the loader takes 2.5 minutes. So just from reading that alone, you need to like have like the loader and truck formulas for production. I kind of like to highlight everything that's important. So like what's being looked at, the time, the cycle times, the truck volume, things like that. So part A asks, calculate the minimum number of trucks you need to transfer 200 LCM of the material. The hauling distance is 30 kilometers. The average hauling and return speeds for these types of trucks are 50 and 75 kilometers per hour. You have favorable dumping conditions, and you must finish the job less than 5 hours. All equipment pieces do not stop during operation. So this part's actually quite important. Since they don't stop at any point, you're kind of just finding the limiting factor for production. So whichever production time is shorter, that'll be your production time. So we have the formulas here. P equals CBVE for the loader and P equals CVE for the truck. So what's important here is that the C stands for the cycles per hour. This is actually quite different from cycles per minute. I mean, cycles, yeah, per minute. Wait, what am I saying? Sorry. So for the loader, oops, sorry. It says in the question that your cycle time is 2.5 minutes. So you just do 60 divided by 2.5, which is your cycle time, which gives you your cycles per hour. So that's 24 cycles per hour. And then you kind of just go through the formula. B is your fill factor. You just look at the table here. For your cheat sheet, I recommend you bring in all the tables that he provides in the lectures and everything, and all the formulas as well. You kind of just, once you have that, like you have everything you need. Like they give you all the value, you just need to look at the tables and fill out the formulas. And yeah. So they said it's well blasted, and the bucket fill factor for a wheel loader is anywhere in between this range. So I just picked 0.8 because that's a nice number, you know. So 0.8, and then we look at the volume. They told us it was 4 meters cubed. Yep, that's for your loader. And then the efficiency, they didn't mention the question, so you just assume it's 1. So for the loader, the production is just 24 cycles per hour times the 0.8 factor times 4 times 1, which gives 76.8 LCM per hour. Any questions so far? Nope, we'll carry on. And for the truck, this one's a bit longer, but similar concept. So you have the formula here, P equals CVE. So they told you the volume of the truck tray is 20 meters cubed, and they didn't mention the efficiency, so you just assume it's 1. And now we look at the cycles. You want to find the cycle hour, but to do that, you need to find the cycle time first. So the cycle time, they gave you the formula. Cycle time equal to. They told you the cycle time is equal to. What does that actually say? The cycle time is the loading time plus the hauling time plus the dumping time plus the returning time. So like in this slide here, they tell you how to calculate all of them. So for the loading time, it's the number of buckets times the excavator loading time. So the number of bucket loads is the truck tray capacity divided by the excavator loaded bucket capacity. So we will write that down as so 20 over 4 plus times 2.5 for the loading time. Does this make sense so far? You kind of just follow the formula. So that is our loading time. Loading. And then we will look at the hauling time. The hauling time, it says it's 60 times the hauling distance divided by the hauling speed. So we would write 60 times 30 divided by the hauling speed, which is 50. And that's your hauling. And then the dumping time, they told us in the question we had favorable dumping conditions. So you're looking at the dumping conditions, favorable, and then it's a rear dump truck, so you go 0.5 minutes. So I put 0.5. That is your dumping. And lastly, you have the return time, which is 60 times returning distance divided by the returning speed, which is 60 times, 60 times 30 divided by 75, which is your return. And if you add them all together, you should get a value of 73 minutes per cycle. So that's just the time in minutes it takes for the trucks to do one cycle. And to convert the cycle time to the cycles per hour, you just do 60 divided by the cycle time, 60 divided by 73, which should give you 0.82192 cycles per hour. Amazing. And now you can just apply back to the production formula, P equals CVE. Now you have all the values, you just do 0.82192 times 20, which is the capacity, times by efficiency of 1, which should give you, 16.438 LCM per hour. Now, just looking at the production time, so the load in the truck, you can see that the truck is the limiting factor because it does less work in 1 hour, right? So you just need to focus on the truck production time. Calculate the minimum number of trucks. So you have, so the time for one truck would be equal to 200 LCM. They told you that there's 200 LCM of material divided by the time it takes for one truck. So that's 16.438 equals 12.2 hours. But we can't, that's over the 5-hour limit. They said they want it done in less than 5 hours. So we try to bump it up to 2 trucks, see how long that takes. So 200 divided by 2 times 16.438, which should give you 6.1 hours. And that's still not less than 5 hours. So you go to 3 trucks and see what that is. And if it's under, if it's under 438, it should give you 4.1 hours. And yeah, that's under 5 hours. So you would say the minimum number of trucks that you need is 3. So you need 3 trucks needed. Amazing. So that's part A. Do I have any questions? Queries? Concerns? No? Fantastic. We'll move on to part B, which is actually quite similar. So they just said, calculate the minimum number of trucks if you use the tray's heaped capacity, which is 10% more. This is actually quite easy. So the heaped capacity would just be, what does it say? 10% more. So you do 1.1 times 20, which is the original capacity, which is 22 meters cubed. And then you just run through all of these calculations again by using VNU. So you need to redo the cycle time with, with 20 here, 22 here, and then use the new capacity of V equals 22. and everything, and then calculate the production time of the truck, and then you can just calculate the number of trucks again, like using 200 divided by the new production time times the number of trucks. It should give you which is 3 trucks, which is like the same as the other, but it's a bit faster. I'll just write the answers because it's kind of tedious. So T1 is equal to 11.25 hours. T2 is equal to 5.62 hours, and then T3 is equal to 3.75 hours. So that's just the answers for if we used the new capacity of 22 meters cubed. But yeah, they will need 3 trucks. It will be faster, but you still need 3 trucks minimum to get the job done in under 5 hours. But yeah, I won't run through the calculations because it's the same thing, just using a different V for the trucks. Do we need time to copy this down? I will move on to the next question. If not, I see some people still writing, so I'll give it like 2 seconds. Zoom out. You're right. I can't even see the lines on the screen. All good? Amazing. So that is question 21. Now moving on to question 22. A bricklayer is planning to construct an unbraced single width wall, 15 meters long, in a region having an expected maximum wind velocity of 96 kilometers per hour. The brick dimensions are 95 width by 57 height by 203 length, and the joints are 15 millimeters. Allow 8% for brick waste and 20% for mortar waste. If the height of the unbraced wall is 2.2 meters, A, calculate the total number of bricks, B, calculate the total volume of mortar required, and C, what is the minimum or the wall thickness so that it meets the safety requirements. Right, so part A. First, we need to find, how do we find the number of bricks that we need? Does anyone know? So essentially, you just need to find the area of each brick and the area of the wall, and you just divide it to see how many bricks you need. Yeah, pretty boring, but it's how it's done. Anyways, so I'll just write down the dimensions. So the brick dimensions, it says the width is equal to 0.0. I'd recommend converting everything to meters because that's what you'll be working with, and it's a bit easier, 0.057 for the height, and the length is 0.203 meters, and the thickness of each joint is 0.015 meters. And then for your wall, the height is 2.2 meters, and then the length is 15 meters. So yeah, finding the area of each brick, you would do the length of each brick, so 0.203, plus the joint thickness, 0.15, and then you multiply by the height of the brick, 0.057, plus the joint width as well. So that is your length of brick, and this is your height of brick. Do we know why we add the thickness of the joint onto each dimension? Yeah? No? So basically, when you're like putting bricks together, you're gonna need the joint. Oh shit, that was kind of bad. Oh shit. Let me just redraw that. So for the bricks, they're not gonna be completely flush on each other. There's gonna be like space for the joint glue, like the cement, to be there. So you need to add that onto each brick. So it's actually this area we're looking for, and then you're multiplying it for every single brick, right? So yeah, that's why we add the joint thickness. And then if you run these calculations, so the length plus the joint thickness times the height plus the joint thickness should give you 0.01569 meters squared. So that is your area for one brick on this wall. And then for the area of the wall, it's really easy. Just the height times by the length, which is 33 meters. Now that you have the area of each brick and each wall, to find the number of bricks you need, so n bricks, you just do the area of the wall divided by the area of each brick. And then you also have to times by the number of walls. They told us it is a single width wall, umbre single width wall, and then there is also a wastage factor of 1.08 for the bricks. They said, yeah, allow 8% for brick waste. So you times by 1.08. And then putting in your calculator should give you 2,270.6 bricks. Now we finish with this question. What do you think, Komodak?
You gotta round up.
Yes, you do have to round up because you can't have 0.6 of a brick. So if you're ordering in real life, you're gonna have to round it up always. And your question as well. Always round up for the number of bricks. Yeah, so that is part A of this question. Amazing. And then part B asks, calculate the total volume of mortar required for constructing the wall. Yeah, similar to part A, the formula for the volume of mortar for each brick is given to you as the width times the thickness times the length plus height plus thickness. So you just plug all your dimensions. That's why it's handy to make a table of your dimensions separating the wall and the bricks, just so it's easier to come back to. So you have your width as 0.095 times the thickness of each joint, which is 0.015, times by the length, which is 0.203, plus 0.057 plus 0.015. And that should give you a very small number, 0.000391875 meters cubed. Always keep your units in meters, just so it's easier to solve volume total later. And then you move on to your volume for the total number of amount of mortar you need. That's just the volume for each brick times by the number of bricks you have times by the wastage, which is I think 20%, so 1.2. And yeah, I don't want to write that number again. So volume for each brick times by the number of bricks, which is 2,271, times by the wastage factor, which is 20%. And that should give you 1.0679 meters cubed. So that's the total volume of mortar you'd need for this wall. Amazing. And flying boots. All good. We'll move on to part C of the question, which is asking, what should the wall thickness be to meet the safety requirements? So you got to look at this table. It's provided in the slides as well. Key points to note is that the formula for the safety height is equal to dt on q, where d is equal to the weight of the wall per unit surface in kilonewtons per meter squared, and T is the thickness of the wall, and Q is the wind pressure. So to find the thickness, you just rearrange it to get H as Q over D. And then they tell you in the question that the wind pressure is think 96 kilometers per hour. Yeah. So you just look at the table here, 96, and then the design pressure would be 0.34. So we write that down. So Q is equal to 0.34. And then D, sorry, the height is, they told you in the question the height is 2.2 meters for the wall. And then D, it's kind of ambiguous, but you kind of have to, it's a brick building, a brick wall. And then you kind of have to like test each thickness to see if it matches up with the weight. So for the first one, I'm just gonna guess like 200. Let's say we think it's gonna be 200. So you do 3.83 for the weight of the wall per meter squared, and then thickness should be, just plugging these numbers in, 2.2 times 0.34 divided by 3.83, which should give you 0.19530 meters, and then you can convert that back into millimeters, which is 195.3 millimeters. So as you can see, this thickness is quite similar to the 200 that you assumed it would be. So if I plugged in, let's say 100, it wouldn't be, you would get a thickness that's different. Like if you use the weight for 100. But yeah, there's only 4 options, so you can just have a try and see which one matches up best. And then, let me see. Yeah, it's close enough to 200, so yeah, amazing. No one's writing anymore? We'll move on to the last question, 23. This is the big question that takes forever to do. So, yeah. You've been employed by the Earthworks company to provide a quote for the loading of 10,000 BCM soil needed for the backfilling of a pipeline. Your company has several wheel loaders. The loaders are in their 4th operational year and have a production rate of 145 LCM per hour. The client wants you to finish the work in no more than 5 days, allowing for 25% overhead cost for management fees and profit. A, how much would this cost? So, what I like to do is every time you use the value from the table, you kind of just cross it out, so you know you won't have to use it again. But yeah, you just kind of work through the operational costs and then the ownership costs as well. So for part A, the operational costs. Firstly, there's 3 components of the operational costs. There's your depreciation, your investment cost, and the ITS cost, which is the interest, tax, and what was the last one? Sorry.
Interest, tax, repair.
Maybe. Anyways, they'll tell you in the table, interest, tax, and storage costs. Oh shit. But yeah, firstly, let's work through the depreciation. In the question, they told you to use the double declining method. Yeah. So that's what we'll be doing. So the double declining method says that it is 2 over the number of years of equipment life that the equipment is in, times by the book value at the beginning of the year. So BV, yeah. So yeah, we find the total depreciation first. Depreciation, which is, as Arian said, it is your initial capital cost minus your salvage value minus the tire cost. So 250,000 minus 22,000 for the 22,000. So that's your initial cost, and tire cost, and then salvage is here. So yeah, initial cost minus salvage minus this tire cost. That's 15,000, and that should give you 213,000. To find the book value at the beginning of each year, So I'll just call this BV naught. It is your initial cost minus your tire cost. So it's 250,000 minus the tire cost of 15,000, which should give you 23. Yeah, so that's your initial book value cost. So to find the depreciation at the end of year one, I'll call it D1, there would be 2/5, where 5 is the number of years that the equipment is in, and it says in the question that it is 5 years old. So we do 2/n, which is 5. So 2/5 times by the book value at the beginning of the year. So 235,000, which should give you 94,000. And now that we have the depreciation at the end of year one, the book value at the beginning of year, well, I guess year two would be, I'll call it BV1 though. It'd be 235,000 minus the depreciation of year one, which is 94,000, which should give you $141,000. And that would bring the depreciation, hold on, just group it like this. So that is the book value at year one. So to find the depreciation of year two, we would do the book value of the previous year times by 2/5. So 141,000. It should give you 56,400. And then that means the book value at the end of year two would be 141,000 minus 56,400, which should give you 84,600. But yeah, it's a very tedious process. You just keep going through the iterations until you hit the depreciation of year four, because the question asks to find, where does it say? In the fourth operation year. So yeah, depreciation of year three would be 2/5 times the book value at the end of year two, which is 84,600. It should give you 33,840, and then the book value at the end of year three would be 84,600 minus the depreciation of year three, which gives you $50,760. And then our last one for depreciation of year four, 2/5 times 50,760, which gives you 203,004. So yeah, the depreciation. What am I saying? Depreciation cost in year four. Wow, why can't I write today? In year four should be equal to 203,004. Let me just highlight that so you don't miss it out. Yeah, that is your depreciation cost in year four. So that is one part of the operational costs. Now you got to move on to your investment costs, which is also in the formulas. So P equals IC times N plus 1 plus S times N minus 1 all over 2 times N. Just grab. So yeah, in this formula, P, it is your average value of the equipment. IC is the initial cost of the equipment, N is the equipment life, which is 5, and then S is the salvage value. And yeah, that's all the components of this question. So what you want to do is just fill everything out. P is equal to the initial cost of the equipment, which is 25,000. Oh, 250,000. Jesus. 1,000. Equipment life of 5 years plus 1 plus salvage value of 22,000 and 5 minus 1 all over 2 times 5. And that should give you, that should give you 158,800 for your P value. And to find the investment cost, you just do P times I, which is investment. P times I, where P is your average value of the equipment, and I is the interest rate. So do 158,800 times the interest cost of interest rate of 6%. So you times by 0.06. And that should give you $9,528 per year. Highlight that. That is your second component of the operation cost. And the final component is the ITS, or the interest. Wait, is interest? Not tweaking. It is the insurance, tax, and storage costs, which is equal to the ITS costs times P. So, oops. That would just be, so yeah, your ITS percentages times P, your average equipment cost. So in the question it gives you here. So use this. We're using these three now. So 1.5%, 4%, and 2%. So it would be 0.015 plus 0.04 plus 0.02 times by the P, which we calculated above here, which is $158,800, which would give you $11,910 per year. Yeah. So after we find the ITS costs and the investment costs and your depreciation costs per year, your total ownership costs would be the sum of all of those. Total ownership costs equal to just adding them all up. So depreciation, 20,304 plus 9,528 for the investment costs plus $11,910 for the ITS costs, which should bring it to $41,742 per year. Amazing. So that is half of finding how much it costs. Now, we move on to the operation costs. So this is the cost that is associated with running the actual equipment, whereas the ownership costs, wait, did I write it wrong? Ah, shit. Ownership costs. This is operation costs. So yeah, for ownership costs, you kind of just have to run through every aspect of these things. So we've used this, we use this, done the depreciation, so for cost, tires, we don't need that, and equipment life. So everything that's left, we still have to use. And then, yeah. So firstly, we'd look at the fuel cost, which is given to you as, everything is in the lecture slides as well. So I'd really recommend bringing all the tables in for each component of the operation cost and ownership cost, just so you don't forget, because you can just run through the tables and see if you're missing anything. So the fuel cost is the horsepower times by the time factor times fuel price times the sum of POC times FCR, which is fuel cost. So HP is horsepower, TF is time factor, FP is fuel price, POC is your percentage of operation conditions, and fuel FCR is the fuel consumption rate. But yeah, looking at this table, the horsepower is equal to 150. So I'm pretty sure. Where's the horsepower? Did I just make that up? Oh, engine side. Yeah, 150 horsepower. And your time factor is 55 over 60, which comes from the 55 minutes an hour. So that's your time factor. Scratch that out. And your horsepower, scratch that out. And your fuel price that's given to you as fuel price, which is given to you as $2. Yeah, $2 per liter. Scratch that out. $2 per liter, and the sum of your POC times the FCR equal to 0.7. So the operation conditions, it says here, so 70% is favorable and 30% is average. So it would be 0.7 times the FCR. Oh, it's one of the tables. I don't have it here. Let's see if I tables. I think it's this one. Yeah, so favorable, and it is what is it again? It is several wheel loaders. So you just look at the table, wheel loader. For the favorable, it's this one, and for average, it's this one. So 0.09 and 0.14. Yeah, just go back here. 0.19. So that's your FCR for a favorable condition, plus 30% of it is average, which is 0.14. And that should give you 0.105. So your total fuel cost will just be the product of horsepower times time factor times the fuel price times your sum of this thingy, which is equal to 150 times 55 over 60 times fuel price of 2 times 0.15 or 105. Should give you 28.88 per hour. Any questions? So that is your fuel. shit. No, we'll move on to the next one, which is your service cost. So service cost, it's actually quite similar to the fuel cost. It's just your horsepower times the time factor times the fuel price times sum of POC times FCR times your SCF. And SCF here, it is just your service cost factor. Also, table 20 in the slides. Yeah. Yeah, 20 for favorable and 30 for average. So we just do it again. Let's just do sum of POC times FCR times your SCF. Which is just 0.7 times 0.09 times 0.2 plus 0.3. This is for your average conditions times 0.14 times, I think I said it was 0.3. So this is in percentage. It's given in the table as a percentage, so you just convert it to a decimal. And then that should give you 0.0252 for your sum of that thing. So it brings your service cost factor or cost to 150 for the horsepower times 55 over 60 for your time factor times your fuel price of 2 times this, which should give $6.93 an hour. Yeah. We're good. Moving on to your lifetime repair cost. And that should just be equal to lifetime repair cost equal to your lifetime repair cost factor. Let's write it down. Lifetime cost factor times by the initial cost minus the price of a fresh set of tires. Price. Hello. New tires. And this can be found in table 21. Should be a bit lower here. Yeah. So as I said, it's a wheel loader, and then for favorable it's here, and average is here. So yeah, for these values where it's given in a range, it doesn't really matter what you pick as long as it's in that range. Yeah, we will do it. So 0.65. So your initial cost is 250,000 minus new tires 15,000. Wait, hold on. Why did I do 0.65?
Lifetime repair cost. This is a lifetime cost factor.
Is it this one?
lifetime repair cost factor. I'm pretty sure that's on a table.
This one.
Which one?
So we'll know the
Operation conditions. Yes, sir. 0.65. No?
it's two.
Because that's the lifetime repair cost factor percentage. What did you use it for?
Just freestyle. So that brings you. So yeah, your repair cost, dollars per hour, is the year digit over the sum of the year digits times the lifetime repair cost over the hours operated per year. So the year digit, it is in year 4 over the sum of 1 to 4, which is 15. Is that right? 4 plus 3, 7.
No, isn't year digit backwards? Like the first one would be 5, the next one would be 4, next one would be 3. So
But it's in 4th year though.
yes, so that would be 2. How many years? 5 years?
Wait, but I got this is not working out. I got it right. Okay. 4, 15 over.
So 1 plus 2 plus 3.
So lifetime repair cost, which we calculated before, which was this thing. It should give you 15,000. So that should be your lifetime repair cost. So 15,2750 divided by your hours operated per year. And for this, it'd just be 19,000, which is given to you. Yeah. 1,900 per year. Just chuck it in there, and that should give you $21.44 per hour. So you use your lifetime repair to figure out the your repair cost. And moving on to tire cost, that is equal to 1.15 times the price of a new set of tires divided by the expected tire life. So 1.15, and you know that it costs 15,000 for a new set of tires divided by the number of hours you expect to use out of it. Where is that? It's here. I'm gonna scratch that out as well. Scratch that out. Scratch that out. And so yeah, 2,100 hours, which should give you tire cost of $8.20 per hour. So you're converting everything into hours for what you think, and then you add it all together in the end to find your total operational cost. Next part of it is your special item cost. So that's like your buckets and blades, all that extra material, I guess. Special item cost. Equal to special item cost. Yeah, it's the sum of the item price, including replacement cost, by the required number of item and divide by the expected life. So in this question, they just told you it's the bucket blades, so you're needing one of them, and then the cost of each is $290, and the life of each tooth is 200 hours, and you need 5 teeth per bucket blade. Yeah, and special item cost. So that would be, first you calculate it for the teeth, which is 100 times by 5 over 200. So there's 5 teeth, and then each tooth is gonna last 200 hours, and it costs 100 per tooth. And then you add on for each blade, which is so you need one blade, and it costs $290 for one blade, divided by the number of hours, which is 250, and that should give you 3.66 per hour. Highlight that as well. Special items cost. And then last but not least, you have your operator costs. So the person actually operating your machinery. And that's just given in the question as $45 an hour. So we can just write that down. Amazing. So that is everything for the operation costs, and then you sum it all up to find your total operation cost. Operation cost is equal to, so what, $28, $28.88 for your fuel cost, plus $6.93 for your service cost, plus $21.44 for your repair cost, plus $8.20 for your tire cost, and special item is 3.66 per hour and your operator cost. And summing those all up, it should give you 114.11 per hour. And then you times, you just need to convert it to, wait, why not convert it to this? I think I converted to, yeah, you convert it to per year, which is 20, yeah, so you just times by 24 to get it in days and 365 to get it in years. And now your operation cost, and your ownership costs are both in money per year, dollars per year. And then, yeah, you just add them together. Wait, hold on. That doesn't seem right. Minimum number of loaders. Anyways. Okay, I'll just move on to part B for now. We have a closer look later. So it says determine minimum number of loaders to complete the work. So we know we're given this in BCM, right? So you have 10,000 BCM. That's your bank volume, I guess. So does everyone know what BCM, CCM, LCM? We all know how that works, right? So that bank is like your natural state. LCM is your, like, after excavating it, it's like the air is filling void, it increases in volume. And CCM is after you've compacted it. So they gave us 10,000 in BCM. So 10,000 BCM. And then we need to know how long it takes. Determine minimum number of loaders. So first we need to convert this bank cubic meters into LCM. So we know that the swell factor is given to us as 20%. So if we look back at the swell formula, it is swell is equal to loose volume. Oh no, it's not. Yes, it is. Loose volume over bank volume minus 1. So 0.2 is equal to the loose volume over bank volume of 10,000 minus 1, and then rearrange it to find your loose volume, which is 12,000 LCM. So now you have all the dirt in LCM. So we look at for one wheel loader 1, it'd be 12,000 LCM divided by 8 times 145. Its production rate is 145 LCM per hour. So that's just one wheel loader. So you, why does it say 8? 5 days. Oh. 8 times. Oh, 8 hours per day. That's why. So you do 8 hours times 145 LCM per hour, and that should give you 10.34 days. And that is not under the requirement because they want it done in no more than 5 days. So you do 2 wheel loaders, which is 12,000. That's your total amount of LCM. So you do 2 of these, 2 wheel loaders, 5, and that should give you 5.17 days. And then that's still not under 5. It's really close, but it's not. So 3 wheel loaders, 12,000. 3 times 8 times 145 should give you 3.45 days. And that is under the requirement of 5 days, so you would say that you need 3 wheel loaders. Yeah. Yeah. Does anyone have any questions? Nope. Yeah. That should be it, I guess. Do you have anything else to say? Like we ran through all the questions. Type shit. Yeah, you're right. That's the last question. I don't know where that is.
Who's the one isn't doing that?
Cam?
Yeah. Isn't Sean right? Is it? Oh, he's gonna send it on Messenger.
So wait, that means I have to scroll onto it, right? I have to scroll onto it, yeah.
Or I can just alt tab.
Oh yeah. Yeah, you're right.
Wait a minute. That's the check.
So if we could just do the attendance form, and then yeah, we're done for today's recap workshop. So just scan it, just fill it out, please.
Thank you.
All right. Now let's have a look. How do we end this? Probably stop recording, right? Yup. This is Randall fixing the last one?
Part A of last question.
Part A of last question. For those
TWK, bro.
those who know. Oh, stream ended. Oh, restream. Alright.
So you have, once you find your total ownership cost, you convert it to days. Hold up. I will speak my truth.
So I actually don't have any other option. I can't write anywhere else. I have to write it. Kind of. It just like usually I have to do it on my laptop, like on my OneNote. I write it down. Yo, that's crazy. So if I'm writing it out, I force
So
myself to actually.
on the last question, I made a bit of a mistake. So after you figure out your total ownership cost and your operation cost, you convert it to amount per day, and then after you kind of have to use Part B to solve Part A. So you find the number of wheel loaders you need and then how many days you need it. Always round up to the number of days. So for 3 wheel loaders, it said 3.45 days will be done. So you round it up to 4 days, and then your total cost will be the overhead, which is given to you in the question. Overhead of 25%, and then times by the number of wheel loaders times by the number of days, and then adding the operation and ownership costs per day, and then that should give you your total cost for the entire operation. Because it spans 4 days, 3 wheel loaders, overhead cost of 1.25, and you're timesing the total the total ownership and operation costs.
Tomorrow? What do you mean? Not today. Today's not over. It's only 2 p.m. It's over.
I actually agree with him.
Today isn't over. You started studying.
Alright, let's see. Stop.